So as you can see through examining the problem description, this is a pretty trivial example which really just involves unit conversion. We're asked how much charge is represented by 5,000 electrons. If you'll recall from reading the course material, we discussed two fundamental ways in which charge can be represented. And which one is preferred really depends on the scale of the problem which you're working. On an atomic or generally small scale, we discuss the fundamental electronic unit, which corresponds to the discrete charge found in either a proton or an electron with varying polarity, of course. The other unit, which we discussed, which is much more prevalent in engineering applications, is the SI unit of charge, which is the coulomb. Therefore, in order to do this conversion, the first thing which we need to do is identify the appropriate conversion factor, which of course is just an equivalent relationship between the two units, which we just discussed. 1 coulomb of charge is a very, very large bundle of charge. In fact, it's equivalent to 6.24 times 10 to the 18th fundamental electronic units. Now, of course, charge is a polarized quantity. It exists in both a positive and a negative form. Therefore, the relationship which I've written is totally one of magnitude. And in this specific problem, we're asked to convert 5,000 electrons, the equivalent charge, into coulombs. Of course, that will be negative, but rather than worry about putting it in the conversion factor, I'll simply append that on at the end. So to perform the conversion, take the quantity which you're given, which is 5,000 electrons, which of course carries a charge of 5,000 electronic units, here denoted by the E with the superscript of negative, multiply by a conversion factor, which removes the unit which we don't want, which in this case is the electronic unit. To remove via multiplication, I'll place the equivalent quantity in electronic units in the denominator to allow for the necessary cancellation. And in the numerator, I'll place the quantity in the units which I wish to keep, which in this case are coulombs. Now really this next step is just simple arithmetic. We divide 5,000 by the quantity in the denominator, 6.24 times 10 to the 18th. Of course, this is something that would be best done on the calculator, although you really can do a quick and dirty sanity check in terms of what answer you should get. 5,000, of course, can be represented in scientific notation as 5 times 10 to the third. Those three orders of magnitude in the numerator would cancel with 3 of the 18 in the denominator, which would give you something that's on the order of 10 to the negative 15th, or if you want to take it a step further, you notice that the coefficient 5 is smaller than the coefficient 6.24, so we're going to have an additional negative order of magnitude. Therefore, we're not surprised when we get the result from our calculator, which says this is equivalent to 8.01, rounded to 3 significant digits, times 10 to the negative 16th coulombs. Now, as we spoke of in the beginning, the original charge quantity which we were given is in electrons, which is a negative unit of charge. Therefore, when we convert units, the polarity doesn't change. That result is still negative, of course.